Yeah, more questions. These were great reference designs. Thank you very much, guys. You guys have put a lot of work into this. It is very obvious. And without having the reference design, we couldn't really do this specification. Specification is a living document for a while until we know if it could work. And then we latch it into 1.0, hopefully by March. So the work that you guys are doing is very essential. Thank you. Maybe we should wait for, we're a little bit early. Should we start or should we wait in case somebody else is trying to join? This is a team effort, so you get to vote. You get to vote. I have a vote for start.
We vote start.
Vote start. Everybody's inside is a little bit biased. So. Oh no, we don't want to be boring. This is a different presentation, customized for this audience. Yes. There's another difference. This morning, 9 o'clock crowd was a 9 o'clock crowd. Now we are all pumped, seeing beautiful designs. Now we see it for real. Now maybe we can have a little bit more enthusiasm and good questions. Right? Okay, let's start then. So, thank you, Mark, for the plug. Yes, it is good to have a conversation about secure control module for OAI as an infrastructure. This morning, the presentation was on secure control module for mostly CPU memory modules, 1-socket, dual-socket, 8-socket eventually. But, okay, so what is the story for open accelerator infrastructure? What do we do there? Similar. So again, the modular building block architecture says let there be different modules that can work together. To do that, we have to have clear boundaries, input, output, dimensions, size, thermal, cooling, and then if we do a good job, maybe they can be interoperable. It was a beautiful display today as part of the reference designs. I could imagine grabbing one of the trays out of one box, plug it into another box. Well, if the management of the two are defined, then I could expect that. Besides the fact that, yeah, PCIe needs to work and software needs to run, management is important as well, right? Okay. I believe that management, the modular building block architecture is a catalyst for this interoperability and increasing the innovation that could be done within every module. Now, the secure control module is an element that can help and assist and facilitate modular building block architecture. It is going to help streamlining the design of the compute element separately from the management element. Management element normally is very specific to the use case, specific to the data center, but the compute element, fabric element, networking element, memory element are specific to the application. Usually there are different requirements for the two. If we are successful in building a modular system, if we are successful in building a secure control module, then we could expect to share common firmware, common diagnostic tools, common debug tools, so that having done one system, we can expect a system similar can be managed the same way in the same data center. So we could articulate some important tenets of a modular building block architecture and then a secure control module for a open accelerated infrastructure. So we want modules to be interoperable. We want clear definition on input and output and interfaces. We want the modules to be stateless, no firmware on them to the extent as possible, so that we could implement security in a central place by the secure control module. So we don't have to have different methodologies for different compute modules. We put all of the bits, all of the control in one place, allow the compute elements, accelerator elements, network elements be as clean as they want to be, and keep the security, control, management in one place. That's the basic idea. Of course, the secure control module needs to eventually connect to the data center, and we use standard means. Nowadays, 1 gigabit is a standard means. Running IPMI or Redfish interface is a good solution. We have been talking about where should this device be, the secure control module, as a plug-in module. Of course, I did talk about that as a plug-in module in 3 different form factors as part of a server architecture for CPU and memory modules. For OAI, it seems that although it wants to be a logical separate element, but the physical implementation, it seems that maybe host interface board so far is a good solution for it. Later, when we have more than one UBB in a system, or more than one host interface board in a system, it might make sense to have a separate module for secure control module. But right now it feels right that it is being part of the HIB. But in all cases, the same firmware should run, the same pin assignment, same schematic should apply to either a separate module or integrated module. Okay, so what is a SCM, secure control module, and its interface? If we can standardize on its interface as the minimum, we are on the right path. So we expect the SCM to be the central element for all kinds of temperature monitoring, power supply monitoring, power monitoring, firmware updates, security against any kind of firmware that we have. That's a part of the secure control module. If it is a separate device, we expect the system to provide power to it. And it will work better if instead of creating 3.3 volts or 5 volt locally, it is better if it receives all the power so that the signals that are on the same power plane, you don't have to isolate them and separate them. They can all use the same power plane. So it does make sense for power to come from outside to the secure control module. But since it is supposed to control everything else, it should be in control of powering up different modules, providing reset logic to them, receiving power OK from them, making high-level decisions, supporting, controlling, monitoring the fan, power supply, all should come from this device. For the security nowadays, people are talking about a separate chip as a root of trust chip. What that device is being debated. Different companies have had different proposals, but the fact that there is a chip there, it seems to be common. We need a security chip. So let's just call it root of trust now. As I say, different companies have different brands for that. We want all of the flash, NAND flash, EEPROM devices to be under control of that security chip. So it is better if they are close to this secure control module, wherever it is. You see that I'm suggesting a lot of things. It is an open source community, And we have not completed this chapter. We are sharing with you what the requirements are. We are looking for feedback even before we have done the spec. So the more feedback we have from you, the better spec we can create. From the system level point of view, we need to consider that different architectures might focus on different variations of these modules. A system can be separate from the host. The OAI as an infrastructure chassis might be disaggregated and be cabled to a host. As an example, this morning we saw one from Zion on Facebook. Or the systems can be all integrated in one chassis. Or one chassis might have multiple compute elements, multiple UBBs, or multiple expansion modules, such as PCIe slots. So let's just consider that if we have a disaggregated host, the host itself has a BMC. If we consider that that BMC is part of the secure control module of that host, then we can have a model that as a data center ready secure control module is on the host and it is being controlled by a rack manager within the data center. Its counterpart exists on the OAI system. Both of them can be connected to a higher level rack manager. Under control of the higher rack manager, these devices can run Redfish or IPMI, and they're happy. They can monitor telemetry, they can control power supplies, and they can help with remote debug. So we should allow this model to work. People are used to running this. In the past, we've had a CPU host node, single socket, dual socket, 4-socket, and an expansion chassis in the form of disk drives or flash or GPUs. We have already had this system before. And having two BMCs running in parallel has worked before. If we did that, then a suitable interface on the cable to the host could be the retimer card that we have already implemented in some of the OCP systems. But it seems that we would like to add a couple of signals to it to make OAI work better. This is just a draft. This is a proposal so far. The team is going to look at it and perhaps enhance it a little bit before it goes to the specification. We should also consider we might have an integrated host within the OAI system. If we do, it is possible for the secure control module that is in the host node be able to control the rest of OAI as well. So the connection from the BMC to the rack manager of the OAI system is an optional element. We will still have a BMC on the OAI just because people are used to doing that. It could have been another controller, a fan controller, a simpler controller. But we think at this point, if we keep it as a regular BMC, people know how to code it, run programs on it. The similar routines will still work. We still have to monitor power supply and fan and I2C devices and JTAG. So it is comfortable. So let's just keep it as BMC. But that BMC could be a subordinate BMC to the secure control module that is in the host. In that case, Rack Manager has only one entry point to this whole world. It can manage everything on one element. If it wants to power everything off, one command does it all. The other model, the Rack Manager has to know that these two systems belong to each other. If I want to power one off, I need to be careful about the other. In this model, there is only one point to start with. As we were thinking about how to do these systems, it seems as though to control the expansion, Whitney talked about the UBB, and UBB has a host interface side, and it has an external QSFP now. And the QSFP can be used for native expansion. So OAMs do OAM to OAM interconnect through an internal UBB or external QSFP DDs. If there is a large data center and if a large system is built that needs to be subdivided, then it is important for the system to provide facilities for some of these links to be turned on or turned off. It seems that we need an expansion manager to control those. We have not defined what that is yet, but we need to. Now, as I said earlier, we need to, as part of the specification, as a base specification, not necessarily forcing everybody to do it, but as a base specification architecturally, we need to define a large system that might have multiple UBBs. If we do, and if we follow everything the same, if we have trays that UBB and perhaps the host interface board are coplanar, it seems that we need to duplicate all of that. By duplicating host interface board, we expand linearly almost the number of PCIe slots we might need, the number of host interface links we might need. So the more OAMs you have, the more fabric you need, the more interconnect to the host you need, and a bigger host you might need. So architecturally, we should allow for BMC to be duplicated. And if it is, then of course the rack manager needs to understand a little bit more. So affinity of one disaggregated host to multiple integrated or disaggregated UBBs should be comprehended. Of course, all of this could be in one chassis. And if it is in one chassis, we know that's a simpler problem. But let's just first solve the disaggregated case and then reduce it, if we need to an integrated case. Again, we need to have a way to control the links, the inter-chassis link or large fabrics that are within rack to rack to rack. We should be able to control them. And we need a facility so somebody up top, a software layer, managing, orchestrating large models. Large models need large systems. Systems need to be interconnected today, but tomorrow you want to break the whole thing up without touching the hardware. So there should be a way for us to cut these and stitch them later. For that, we might need an external expansion manager. This is, again, an outline of, from here on, several slides I have go in a little bit more detail of if we were to do secure control module as a entity by itself, what type of jobs it might do. It might, again, provide permission for different modules to wake up, power up. And based on that, it needs to know that yes, all of these modules have powered up. Once every module powers up, then it knows that, yep, system is good, so it can assert system power good to everybody else. And based on all that, the modules go around and say, yep, I'm powered up, my voltage regulators are okay, and if they're not okay, they will vote on that. And eventually, system comes up. So, yep, we need to have a hierarchical, architected power-up sequence and voltage monitoring as part of secure control module. You have probably seen some of these diagrams before. This is one particular implementation on the reference designs of today for UBB. The interfaces that we should define, if it is a module, it should have a defined interface. For secure control module, we have secure control interface. If the secure control interface is on a separate module, or if it is as part of HIB, host interface board, it still has to have the same look and feel interface to the UBB. So we should define an interface, in this case OAI, Secure Control Interface, that is well defined. Every one of us in a year or two know every one of those signals. These signals will be famous signals. They will sit there forever and ever and ever. So we need to define what those are. Today, they are defined. They are part of large high-speed signals, high-speed connectors today, but they are there. We should need to identify them, put them in one bucket called SCI, and then later, if we have those modules done as a separate module, we carry the same signals, the same definition, so that the firmware written for one BMC will work in the other case as well. So there are details of what those signals are. Now, sometimes we run out of pins, or pins are expensive. Connectors are, these are high-speed connectors, and we're using them for low-speed signals, so we should reduce the number of pins that we use. And you guys know time division multiplexing is one way to do that. And a very simple method is using shift registers or muxing or demultiplexing concepts. So UBB, you've seen that has a CPLD already for reasons necessary for BMC controlling the root of trust chip and flash devices and such. It will also have a CPLD. So it is very reasonable to connect the two CPLDs and run a shift chain between the two so that we can have only 4 pins, but many, many signals loading on that. So we'll have dedicated signals, signals that are being conditioned by CPLDs, and signals that are being time division multiplexed to carry more bits. So that will be as part of the OAI-SCM specification that we will hopefully by March complete. Now, from here on, you have seen these, but I'm going to show it in the form of, if we were to do these functions as part of SCM, what would we do? So the right-hand side is what we saw UBB needs to do. The left-hand side is, in this case, is a JTAG tree that will be done as part of SCM. The same, Whitney showed that, the UBB wants to be controlled, monitored using UART. Okay, who should run that UART? Who should be the master on that UART? It should be part of the secure control module. The same 5 I2C buses that Whitney showed is coming from UBB. Who should run that? Who should be the master on those? It should be the BMC that is part of secure control module. Same thing for any kind of throttling or power or thermal protection. All need to be controlled by the center of management and security, secure control module. So, in summary, we have created the open Accelerator infrastructure based on a modular building block architecture. Modular building block architecture is not to limit you at all. It is there to facilitate innovation in different areas at different times. We might start with a power distribution of a kind, 12 volt, 48 volt, or AC, and somebody might say, mine is better. We say, we love it, bring it in. So we can change that one. Or UBB itself, or the OAMs, or the secure control module. Each different module can be innovated upon. After 2-3 years, we might all agree that doing it one particular way is better than other ways. From then on, we just make it quiet and make that one the standard. Hopefully a de facto standard will emerge. And if we do it right, systems that good companies such as the 3 reference designs that we had today built can fulfill any data center, because there might be at some point a secure control module specific to a particular hyperscaler data center that the systems that you guys build can connect and very soon make them data center ready. That is basically the vision here for secure control module. Otherwise, without that desire, it's a lot of pain to do it in this way. Hopefully there is a gain from that. So, in you're doing any kind of design, please think of it in a modular way. Think about the data center ready secure control module as a central element. So we do it once and replicate it several times. Thank you.
Just a question. When you talk about security, some of the implementations, like if you look at TPM, they have like a secure screw where screw down once so it can't be physically removed. Does the SCM spec, or will it include some sort of secure retention or something so that can't be physically?
We should define the specification in such a way that certain things are optional, and although they're optional, the specification should say, if you do it this way. So we cannot force all systems to be exactly the same, but we can help guide that if you were to do it, it will be interoperable in some other environment. Customers will eventually dictate what they need, and the customers are not necessarily hyperscalers. A data center in a particular region might have different requirements. So we need to architect it in such a way that you can optionally change it, but each option should be a useful option. Good question, thank you.
Like China versus the US?
Exactly. Certain regions allow TPMs if it is a special way, or certain other regions don't allow TPM at all. And the same thing with the root of trust chip. It might be different kind. Any other questions?
So you mentioned earlier this morning about different cloud service providers have different flavors, if you will, or different requirements. Are these all only available under, you got the show and tell, under NDA, or are these publicly documented requirements?
Okay. Fred is talking about my story today. So very good question. One of the things that slows down innovation and progress is time required to come up with requirements. A lot of good people, good suppliers come and say, hey, tell me what you want, I will build it for you. I said, I don't know what I want. Come back in 6 months. Comes back in 6 months, my ideas have changed. I've changed different clothes, I've picked up a new sports, requirements have changed. So it would be great that although we create modular systems, we can have a vendor, a supplier, build the entire system, CPU control module, accelerator module, and its own secure control module. They're all built together as a whole, so this is a solution that's already working. And then when they present it to a particular data center, that particular data center might say, I'm not a blue guy, I'm not a red guy, I'm a blue guy. Well, if the interface, the secure control interface that we have defined is the same, then this data center hyperscaler can plug in a particular cap or secure control module that was already designed for some other system and make this whole. So the entire system can be designed ahead of the requirements and be ready to be adapted to the requirement of that particular data center. The same is also true the opposite way. A data center having designed a secure control module might receive compute modules, storage modules, expansion modules from different companies, because they did something wonderful on their own. They didn't know what my requirements were, but whatever they did is lovely. I'd like to integrate it in the data center as quickly as I can. If the plug works, if the secure control interface is the same, my rack manager, my data center manager plug can make this one look and feel exactly like what I'm used to, doing the remote debug, doing the security, doing monitoring, doing control of everything the same way. Therefore, we can go to production faster. And everybody gets to money, TTM, time to money, as soon as possible. Did I capture it?
Yeah, I was just asking if what's specific to, for example, Microsoft, is that published, or is that only available under NDA?
The interface will be published. The modules, maybe because it is a security issue, might come from a very secure place, or it might be public. Certain aspects of it might be public, and certain aspects of it will be okay. It is okay to keep secrets, but we want it to be still interoperate. Okay, thank you.